In this problem, we're told that a new law is expected to cut drunk driving by 5% each year. Initially, there are 5,000 cases of drunk driving in a particular city. Create a table that shows the number of drunk driving cases over the next 5 years. Okay, so we want to take a look at time, and we want to look at the number of incidents. So we'll say number of drunk driving incidents. Okay, so initially we know there are 5,000 cases. Now in 1 year we expect the 5,000 to be reduced by 5%. Well, of the 100% that we had representing the 5,000, we now have 5% less. So that means to figure out what's remaining, we'd still have 95% of the previous year's cases. So we would multiply 5,000 times 95%, and that would give us, oh, well, let's write these out first. 5,000 times 0.9, oh, excuse me. So this would be 4,750. And then we would take the 4,750, and the next year there would be 95% of that. Well, that would give us 4, 5, 12.5. And then we would take that amount and we would continue to multiply it by 0.95%. Or excuse me, 0.95. And we would continue on in this fashion. Well, the simpler way is to see that the year 2, you took 5,000 times 0.95. That gave you 4,750. Well, then you took that entire amount and you multiplied by 0.95 again. So really what you did is you multiplied 5,000 by 0.95 2 times. So this 4512.5 should also be given to us by taking 5,000 times 0.95 squared. And you guessed it, to multiply and get 4286, you multiplied by 0.95 again. So that's really just 5,000 times 0.95 to the third. So we'd continue on in the same fashion. In letter B, we want to create a graph out of this data, so I will generate one using Excel. Excuse me, not Excel, my graphing calculator. So I have my equation in here, 5,000 times 0.95 to the x, and I want to be able to look at the correct windows. So I'm going to go from about 0 to 5 years, since that's what we had in our table, and this is an important time to think about domain and range. So in year 0, we know that our number of drunk driving cases was at 5,000. I'm going to set this to 4,000, excuse me, just to be able to see a little ways underneath the graph. I'm not going to go all the way down to 0, or else I may not get the full shape. Well, it goes as high as 5,000, so I am going to mark this thing down to 5,000, and I'm going to graph it, and there I get the shape of my graph. Now you notice there isn't too much curvature to this one, but if you started to zoom out, you would begin to see some, because as you take a smaller percentage, the same percentage of a smaller and smaller amount, that amount of decay gets smaller and smaller. So you're noticing it's not going down by a constant rate, it's actually starting to kind of slow down a little bit. And if you start to look at the differences between years, the actual difference is not that much. So we did this already. In letter C, what decay factor do we multiply by? Well, that was 0.95, or 95% of what we had the previous year. The initial value in this case is 5,000, because that's the starting number of cases. Write an equation of the form y equals initial value times decay factor to the x power to give the number of cases as a function of years past. Okay, well, we already know this. We know that the number of drunk driving cases is equal to taking 5,000, multiplying it by 0.95. Well, how many times do I do that? Well, it depends on the number of years that have passed. So that's what my equation would look like. How many cases will it be in 15 years? Well, now I can just type in 5,000 times 0.95, raise it to the 15th power, and we have about 2317 cases. 2,317 cases.